Hello, and welcome to this talk on building an ASP.NET application with MongoDB. My name is Caleb Thompson, and I'm a developer educator here at MongoDB. In this talk today, I'm going to show you how we can access data in a MongoDB store with an ASP.NET application using the C# driver. The first thing we'll do is we'll set up an Atlas account and install some sample data. Atlas is MongoDB in the cloud, and it's a free and very convenient way to get up and running quickly without having to install MongoDB locally. So we'll do that first. And then we'll switch over to Visual Studio. We'll create a new ASP.NET app. We'll look at the default code that's in there. Then we'll switch back to the slides and spend a little bit of time looking at how you can use the driver to access the data that's sitting in Atlas. We have a bunch of choices in how we do that. We'll look at building what are called mapping classes to access the data easily, and then we'll do some reading and updating of the data from the application. So the first thing we want to do is set up an account in Atlas. We'll create a new shared cluster, which is free, and in that cluster we will then import some sample data that we will use with our application. So what is Atlas? Well, Atlas is MongoDB running in the cloud. It allows us to easily have a MongoDB instance running without having to worry about any sort of server maintenance, and that can save us a lot of time. You can choose to run Atlas, as we'll see in just a moment, in one of three cloud providers, AWS, Azure, or Google Cloud. And it is self-serving, elastic, it's scalable, global. We have enterprise-grade security, monitoring, managed backups. There's also a serverless platform, which we won't look at in this talk. So for a lot of reasons, Atlas is a great way to just get up and running with MongoDB very quickly. Of course, you can use a local installation of MongoDB if you already have one running for this talk, but I'm going to show you how to do it with Atlas. So let's go ahead and take a look at Atlas. I'm going to switch to my browser here. Okay. If you don't yet have an Atlas account, go to cloud.mongodb.com and create a new account. It's free. Once you're in, you'll have the option to build a new cluster. So we're going to do that. And I'm going to choose this left-hand column. You'll notice the word free here. For our purposes, a free shared cluster is just fine. So we'll create a cluster. As you'll see, you can choose what cloud you want your data to be stored in, AWS, Google Cloud Platform, or Azure. I'll just stay with AWS for now. I'm on the West Coast, so I'm going to pick Oregon. Not that it really matters. As you can see, I haven't changed anything that would charge, so it's still free. If you want, you can change your cluster name here. I'm just going to keep it at cluster 0 for now. And I'm going to click Create Cluster. Now this process takes 1 to 3 minutes, so I'm going to pause while that catches up. And there we go. We now have a new cluster named Cluster 0 that's been created for us. We have 3 buttons: Connect, Metrics, Collections, and under the 4th one, we have some other options that we're going to take a look at in just a minute. But let's click on the Connect button first. You'll notice when we open this dialog, it says you can't connect yet. Set up your firewall access and user security permissions below. So by default, our Atlas service is turned off, or rather it's turned on, but nobody can actually get to the data. So the first thing we need to do is whitelist the IP address or addresses that are going for the machines that are going to access the data. You can easily do this just by clicking the Add Your Current IP Address. An insecure way to do this also is add a different IP address, and you can enter the CIDR address 0.0.0.0/0, which means every computer can access the data, or at least theoretically can. I'm just going to add my current IP address and click on Add Address. Now, the second thing we need to do is create a MongoDB user. So let's do live 2020 is the user, and live 2020 pass as the password. Make sure I type that correctly. Yep. and then click on Create MongoDB User. Of course, if you're following along, you can create a username and password, whatever you want, and your IP address obviously is going to be different from mine. Click on Create MongoDB User. I don't want to save it. And that's it for now. We're going to come back to this choose a connection method in a few minutes. Let's go ahead and close that. You'll notice now that Atlas is updating with our IP restriction and our new user. Should be just a second. And when that's done, we will import some sample data that we'll use for the rest of this talk. Okay, we have added our IP address to the whitelist. We've created a MongoDB user with a password. So now let's go into this ellipsis and we're going to choose Load Sample Dataset. Now obviously if you're using your own data, you don't need to do this. This is really handy though if you're giving a talk or a demo. So it just says, are you sure you want to install this sample data set? And we go ahead and load that. Now we'll give it another minute or so to import all of that data, and then we'll explore it for just a minute. Okay, and it is now loaded. Let's take a quick moment to explore what that might look like. Let's go to Collections. Okay, we can see that a bunch of data has been installed for us. Looks like about 7 collections, sample Airbnb, sample analytics, etc. You can use any of this data for your projects. There's a good diversity here. In particular for this talk, I'm going to use under the sample geospatial collection, there is a database called shipwrecks. And if we take a look at that, we can see that there are 11,095 shipwrecks in this collection, with some fields like feature type, chart, latitude, longitude, water level. There might be some interesting stuff here. So we're going to go ahead and use this for the rest of our talk. Okay, now that we have a data store we can play with, let's go ahead and switch to Visual Studio and get to work on building an app. We're going to create a new ASP.NET Core web app. We're going to use NuGet to import the MongoDB driver. We'll initialize the MongoDB client. We'll instantiate a database and collection object, and then we'll read some data. Let's go ahead and switch over to Visual Studio. And we will choose to create a new project. We want to choose an ASP.NET Core web app. Next. And we'll keep the default name. Create. Okay. And let's choose, let's see here, a React.js app. We don't have to do any front-end work in this. I like React and it's handy, so let's just go ahead and choose that for now. We'll keep it simple and we will create. Okay, it has now created a new app for us. Without doing anything else, let's go ahead and run it and just see what it looks like. Now, the first time you run it, you'll notice in the output console window there that it is restoring dependencies using NPM. That's all necessary for the React front end. Again, it's something we don't need to worry about in this talk. It takes a minute the first time you run the app, and then after that, we shouldn't even notice it. And I'll also note while we're waiting that I'm running this in Visual Studio 2019 Community Edition on a Windows box. Everything I'm doing, though, works just the same on a Mac, in the Mac OS with Community Edition 2019. Okay, so here is our default application. A nice hello world page rendered in React. And you'll notice that there is a link over in the upper right corner called Fetch Data. What this does is it loads a React page that behind the scenes is calling our controller and fetching data. So if we look at the developer console on this, make that a little bigger, and refresh the page, you'll see that it is calling a get call here to our localhost / weather forecast, which is the name of our controller. I'm going to go ahead and copy and paste that. What I'm doing here is I'm just bypassing the front end, the stuff that makes it look pretty. And you can see that the controller is currently returning an array of JSON objects, or a collection rather, that have a date, a temperature, and a summary. Okay, if we go back and look at our code, let's go ahead and stop this. And we go to our weather forecast controller right here. You can see that when we call the get method, which is what's happening behind the scenes, we are returning a random selection of these summaries up here, as well as generating some random temperature ranges. Interesting, but not all that useful because it's all fake data. And obviously what we want to do here is use our sample data in MongoDB. So let's look at how we do that. Okay, I'm going to clean up a little bit here. I'm going to get rid of this static summary array of strings, get rid of we'll leave the logger for now. And in the get, I'm just going to get rid of all of the code for a moment. Okay, none of that is useful to us other than showing us that it works. And I'm just going to add a return null for the moment. So what we need to do now is add the MongoDB driver to our project so we can actually access some data. There are several ways you can get to this. We're going to use NuGet. I like to right-click on the dependencies and choose Manage NuGet Packages. If you're using Visual Studio on the Mac, your UI will look a little different, but the idea is the same. You want to find Manage NuGet Packages, and we'll go there, and you need to switch to the Browse tab, and we're going to type in MongoDB. A surprising number of results come back. The one we're interested in is, in my case, the second one, MongoDB.driver. We're going to choose that, make sure it says latest stable version, and install. It'll ask us to accept the license, and of course we will. And that's it. We can switch back to the Installed tab and see that it has indeed been installed. Okay. So we can also see it here under Dependencies in case you really want to believe it. Under Packages, there it is. So let's switch back to our controller. And what we need to do now is create a Mongo client, which will define how we connect to our data store, whether it's local or in Atlas or wherever, right? So var client equals new Mongo client. And it's not going to recognize Mongo client until we use the namespace MongoDB.driver. And there it is. Now, when you new up a client, you have to pass in the connection string, the URI, to wherever your data store is, whether it's local or in Atlas. It's not something I have in the top of my head, but fortunately we can go back to our Atlas page and go to our clusters right here. And you'll remember this connect button from a few minutes ago where we set up the IP whitelist and our database user. This time when I connect on it, I'm going to choose the second option down, connect your application. And make sure you select under the driver, the C#.NET driver and the latest version. And then you'll notice right here, the connection string has already been generated for us. So I'm just going to click copy, switch back to Visual Studio and paste it right in there. Okay. Now you'll notice that in the connection string, our username has been added, but not the password for security reasons. So let's type that in, live 2020 pass. Okay, so now we have a Mongo client. This is pointing to our Atlas store. What we now need to do is tell our application which database and collection we actually want to use. What data do we want to get? So I'm going to switch back to Atlas again for a moment. I'm going to close that screen and go to collections again. And we decided we're going to use the sample geospatial database with the shipwrecks collection. Okay, sample underscore geospatial. So here I can do var database equals client dot get database. And in there, again, we put in a string, sample underscore geospatial, like so. Then from that database object, we can create a collection. Var collection equals database dot get collection. And it is called shipwrecks, like so. Now you'll notice that we've got an error here in the IDE. Get collection expects us to tell it what type of data we're going to be getting. And we don't know yet. If we look at our shipwrecks data here in Atlas, as we did a few minutes ago, it's just data. It's a bunch of JSON documents we're going to get back. Okay, so we're going to need to do something here to translate this JSON to something in C# that makes sense to us. Okay, if we don't want to, if you don't know what's going on, you just want to have a quick and down and dirty way to get the data, you can always pass in bson document object type. Okay, this is generic. Yeah, it always fills in automatically there. This is a generic class that defines any JSON object, and you have to import the MongoDB.bson namespace. Okay, so that will work, but it might not be very useful for us. We now have a client object. It is pointing to our Atlas cluster. Within that cluster, we're telling the driver that we want to use the sample geospatial database. Within that database, we're specifically looking at the shipwrecks collection. And with that information, we can then do something like collection.find and get out the data we want. We can specify what we want. Before we go any further, though, I'm going to switch back to the slides so we can look at several different ways we can access the actual data using the driver. There are 4 ways we'll look at, and then we'll switch back to our code and make it happen. Okay, so let's spend a minute talking about how we actually access data in MongoDB from the driver. There are 4 main approaches we can take, and here they are. You can use the MongoDB query language, MQL. You can use the bson document object. The driver provides these things called builders, and we'll take a look at those. And then finally, the most robust way to do it is to build mapping classes and use a link. And hopefully you'll see why a little bit of time spent up front using mapping classes will save you a lot of time later on. Well, let's go ahead and take a look at the 4 ways, because these are all valid approaches you can use depending on your needs. We're going to assume for a minute here that we have a collection somewhere in MongoDB of guitars. Each guitar has 4 properties: an ID, make, model, and price. Okay, so we're going to use this. We're going to pretend we're going to query for all guitars over $400, and we'll look at those 4 different approaches to doing just that. Okay. So this is what the collection would look like in MongoDB. We've got, in this example, 4 JSON documents. Each one has the same 4 properties: ID, or excuse me, underscore ID, make, which is a string, model is a string, price is a double. Okay? Simple data here. So if you're familiar with the Mongo query language, you can continue to use that by simply passing a string that contains valid MQL into your find or any of the other CRUD methods we've got. In this case, we're creating a string property called filter. It contains a valid MQL statement, which is saying I want all of the documents where the price is greater than 400, and we're passing that in, and we will indeed get back what we expect. Now, if you've got something you want to do very quickly and you're familiar with MQL and you're good at typing, this is a perfectly valid way to do it. It is not, however, at all type safe. If you typed price wrong, or if price were capitalized in the database, or something like that, it's not going to work. You won't know it won't work. You just won't get the data you expect. Your users won't get the data they expect. So works, but not great. Okay. Now you can also use a bson document object with the driver. What this does is it provides a little more structure around your MQL, but not a whole lot. As you can see in the bolded line here, we're creating a new BSON document. We're saying the field we want to query on is price, and the value is another BSON document, which is greater than and 400. Okay, it does exactly the same thing as this previous slide right here, but it's wrapping it in a BSON document. It provides a little bit of type safety, but again, not very much. Okay. Now, if we had a slightly more complex query, very slightly, like we want to get all the guitars between $400 and $600, in MQL, you can see the line up here. You create an and, a $and, and specify a price greater than 400 and a price less than 600. Okay. Converted to the BSON document, now we have to create a BSON array for those various properties. It gets a little bit longer, and you can see that if you had a complex query, using the BSON document approach really can lead to some pretty long, wordy code, verbose, okay? Which is one of the reasons why the driver provides this builders class. Now, a builders class, you specify the type of document you want to build. You say you want to build, in this example, a find filter, called filter. And you can see that the builder now has some properties like GT for greater than. You can pass in an ampersand for and it also has an LT for less than. So that same query of all guitars more than $400 but less than 600 can be handled in a more graceful way. You don't have to remember to do $GT or any of the other MQL specifics to get this to work. It's also a lot shorter than using a BSON document. So this is definitely better. Still not my preferred approach. My preferred approach is much more .NET friendly, and that is using mapping classes. A mapping class is just a C# class that defines the properties that we expect in the data and that we care about and that we want to use. We can name them whatever we want, and then we can tell the driver how to map those to the actual data in the data store. So as you can see here, we have a class called guitar. It has 4 properties in ID, make, model, and price. They're all capitalized in this case because that's how we generally define properties in C#. Okay, so here's a side-by-side comparison of the mapping class on the right and the actual guitar object as it's stored in MongoDB. Now, by convention, a public property named ID with a capital I, lowercase ID, or underscore ID is always used as the identifier. You can specify a different field if you want by using the BSON ID attribute. We'll look at attributes in the next slide. But you can see that otherwise, this will work. We haven't told MongoDB, we haven't told the driver anything about how to map these, but because they have the same names other than the initial capitalization, the driver is smart enough to say, you're looking for something called make with a capital M, here's a make in the data store with a lower m, I'm going to assume they're the same. Now, assumptions can be dangerous, so the driver also provides attributes that we can use to make things very explicit. Okay, the BSON ID attribute says, even though I've named this property guitar ID, it is the ID for the document, and so it's going to be mapped to the underscore ID in the data store. Likewise, I don't really like the names make, model, and price. I want them to be more user-friendly. So I'm going to call them manufacturer, model name, and price in dollars. And for each of these, I'm going to use the BSON element attribute, passing in the name of the element as it exists in the data store. Okay, so now we have a C# class called guitar. It has property names that we like and we want to use, and we're telling the driver explicitly how to deserialize and serialize between this and MongoDB and the fields that are there. Okay, now that we have a mapping class, we can use a link. Now, link is the query language within .NET Framework that allows us to do structured querying against any number of different kinds of data stores. So, of course, the driver implemented it to work with MongoDB. In this case, we have a expensive guitars variable we're assigning, which is the guitars collection where the guitar.price is greater than 400, and we're going to return that as a list. Okay, very straightforward link statement right here. And you'll notice that we have 100% type safety. We can't do g.price with a lowercase p or misspell it PRCE, something like that. The compiler will yell at us. Actually, the IDE will yell at us before we even compile. So using a mapping class and then using link provides us with great type security, makes it really easy to write complex statements using link, which most of us are probably familiar with at this point. If you're not, it's time to be. And so here's a more complete example where we have the collection. You saw a minute ago in Visual Studio, we newed up a collection, and we can now call on that collection the find method, passing in the link statement, specifying how we want to filter what we actually want to find, and then we're returning it as a list. Okay, so now that we have all of that, let's go back to our app and do some refinement and see if we can actually display data from MongoDB in our what is currently a weather data app, but we're going to use the shipwrecks. Okay, so here we are back in Visual Studio, back in our controller, and we've got our client, our database, our collection. Right now the collection is saying it's of type BSON document, but that's not very helpful to us. We now know we want to create a mapping class. Let's go ahead and do that. I'm going to right click and choose add class, and we'll call it shipwreck. You can call it whatever you like, but obviously a name that is sensible is always good. Okay. Now I'm going to go look at our data in shipwreck again for just a moment here. I'm going to clean that up. And shipwrecks. Okay, it looks like we have an ID and a whole bunch of fields, some of them strings, some of them doubles, that may or may not be useful. So let's start with ID feature type chart. Okay, so we have public object ID, and it's called ID, and we'll put a getter, etc. on that. Okay, it doesn't seem to recognize this object ID. We need to import mongodb.bson. Okay, and then we have a public string feature type, and we'll getter setter. We have a public string chart. Okay, what else? Now this lat dec and long dec are doubles or decimal values of the latitude and longitude. Now it seems really important if you're doing some app that's showing where shipwrecks are. So let's go ahead and include those two. Public double latitude. You'll notice that I'm not using the names that are in MongoDB because lat dec and long dec mean nothing to me. I'm using something that makes a lot more sense. If you don't know about latitude and longitude, don't worry. That's just a way of describing where something is on a map, or on the planet, actually. Okay, now, notice that I didn't use the same names, so we need to go back and we need to do some bson element, attribute element, and we pass in the name of the element as it appears in MongoDB. So that was called feature type. I'm going to go back and double check these. And again, we need to add a reference here to bson serialization. Okay. Let's make sure we get the names feature underscore type chart, lat dec, long dec. Okay. Let's go ahead and copy and paste a little bit. We don't need to add one for chart, interestingly. I'm doing it anyway for the sake of being thorough. But again, the driver is smart enough to recognize that the only difference is the capitalization. Now this was lat dec and lawn deck. I'm going to just double check those. Lat deck, long deck, okay. We can specify here that this is the BSON ID, like so. Now, there are also a whole bunch of fields in the database that, for the time being at least, we don't care about. Okay, I don't know what this GP quality is. Depth might be interesting, but for now, we want to ignore a bunch of stuff. And there are two ways we can do that. Okay, we can create a property, a public property of type object, an array of objects called whatever you want. The bucket, I'll call it, right, with get and set. And if we put, it would help if I could type, if we put on this bucket a BSON, or an attribute called BSON extra elements, like so, anything that the driver finds when it's serializing or deserializing that it doesn't recognize as one of the properties we have already specified, it will throw it into this object array as a key value pair. Okay, that's one way to do it. The problem with that is you end up with an array of key value pairs that you still don't really care about. So you're getting back more data than you need, and somewhere on the front end you're going to have to deal with that. So another option is to get rid of that, and on the class itself add a BSON ignore extra elements tag. Okay, so that just tells the driver throw away anything you don't recognize. We don't care about it for now. Very handy. And that's it. So now we have a shipwreck mapping class with names that we like that mean something a little more useful than what's in Mongo. Let's go back to our controller. And here we're going to change our get collection from a type of BSON document to a type of shipwreck, because we now can do that. Okay. And then let's do a find and see what happens here. Let's do, we want to return the collection dot find. We'll add some link here. Let's see. Let's find shipwrecks where the feature type is Rex visible, the first one that I see here. Okay, Control C. S dot feature type equals Rex visible. And it's yelling at us because we're supposed to be returning an IE numerable. So let's do a toList. Okay, like so. Now we're asking it to return an IE numerable of a type called weather forecast, and that's no longer valid. So we'll change that to shipwreck. And we'll get rid of this return null line. It's no longer needed. And that should do it. Let's see if we did it right. Build the app. Okay, we'll go to our, well, we'll open up our console again. We'll go to fetch data. And again, I'm going to go ahead and bypass the front end altogether and just go straight to the API call to the controller. And look at that. We have a page now returning a whole bunch of JSON objects. They have an ID, feature type, which again we specified Rex visible. If we go through this entire list of hundreds of them, they should all have Rex visible. Indeed they do. Well, I guess 2 isn't proof, but there it is. And we got our latitude and longitude back. So that's how we connect our driver to the MongoDB store. Okay, now this is great. We've got it working just like we want it to. But there's a little bit of a problem here. And that problem is that within the method of the controller, within the get method, we're creating a new Mongo client every time, a new database object, a new collection every time. And if you're following MVC patterns, this probably smells a little to you. And that's because we don't need to do this every time. This controller, which is still named our weather forecast controller, but our shipwreck controller probably is always going to be using the same collection, shipwrecks, right? So there's no point in having all of this code in every method of the controller. In fact, we may have multiple controllers in our project that are looking at different collections within the sample geospatial database, or maybe they're even still using the same collection. So there's got to be a way we can do this, we can clean this up a little bit more. And I want to take a quick look at that, because this is not a best practice the way I've got it right now. Okay. In ASP.NET Applications, there is a startup.cs file right here. Okay. This is where we do all of our initialization code. So it seems logical that we would initialize our Mongo client here and then have the ASP.NET Framework inject that client into our controller where we can then use it. Okay. Let's go back to our controller for a minute. And so what I'm saying is we want to inject this client. We don't want it here anymore. I'm going to get rid of this on this constructor. Right now it's expecting an iLogger object. I'm going to get rid of that. And what I really want to have come in here is a Mongo client. We'll just name it client for now. Okay. And I'm going to get rid of this property, this private logger. And instead, I'm going to do a private iMongo. Now, let's assume, and I think this is a safe assumption, that every method we want to do in this controller is always going to be using the shipwrecks collection. It is, after all, the shipwreck controller. So let's do an iMongo collection. We'll name it shipwreck collection. You can name it whatever you'd like. Shipwreck collection. It's better if you spell things correctly. And what we're going to want to do is set here the code that when we get the client in, we create the collection. So let's take this code out of our method. Okay, these two lines, I'm going to cut those, put them in our constructor. Okay, change this now to shipwreck collection as such. Okay, so now when this controller is initialized by the framework, we need it to pass in an iMongo client object. We will use that client to get the database. We will use the database to new up the collection. And then down here, we just change, we get rid of the client line down here, and in the method, we just change collection to shipwreck collection. Okay. Now it's yelling at something here. We haven't specified the type. It is of type shipwreck. Okay. In our startup.cs, in the configure services method, we want to create a new Mongo client that will get injected. So let's do services dot add singleton. Specify the type Mongo client. We want a Mongo client out of this deal. Okay. And let's see here, we'll use a little bit of link. What do we want to do? We want to return a new Mongo client, like so. I didn't mean to jump the screen. Okay. And here we would pass in that same URI that we had in our controller. Let's go back to our controller. Do we still have it? No, I deleted it. That's okay. Okay. That's one way to do it. A slightly better way to do it is ASP.NET projects come with an appsettings.json file. This is a convenient place to store configuration information, like, for example, a Mongo URI. So you can create a new property, and you can set it to whatever you want. Let's go back to our Atlas, and we'll go to our cluster. We'll go to connect your application. Now, if I hadn't deleted it already out of my project, I would just copy it from there. We'll copy that string one more time, paste it in here. Okay. And again, we need to put in the password, live 2020 pass. Make sure that's all saved correctly. Okay. Now that we have that, we'll go back to our startup again. And what we want to pass in here is some URI. And that URI, we want to do s.get oops. I want to do s dot get required service is of type I configuration, and we want to specifically ask for the Mongo URI property we just created, like so. Okay. So I forgot the variable there. And that should do it. I'm going to double check that I got Mongo URI that matches the property name here, Mongo URI. Okay, so now we're saying get the configuration service, within the configuration service, get the Mongo URI property, set it to this string variable, and then new up a Mongo client passing in that connection string. At this point now, we should have automatic injection of this client into our controller. We'll then create the database. We will assign the shipwrecks collection to the shipwreck collection global. And in our get method now, we should see exactly the same data. So let's fire it up and see if we did it right. Okay, there's our page. We'll go to fetch data, and we will go directly to the back end. And sure enough, we're still getting the data we expected, except now we're not doing it within the controller method itself, and we can reuse this shipwreck collection throughout the controller for all of our different methods. Much cleaner, much better practice. With that, let's switch back to the slides. Okay, so in this talk, I showed you how to set up a new Atlas account and a new cluster within that. We imported some sample data that we used for our app. We then switched to Visual Studio, created a new ASP.NET app, and from there, I showed you how to import the MongoDB driver using NuGet. Once we had the driver installed, we initialized a new Mongo client, passing in the URI to our Atlas data store. We created then a database and collection object off of that client. We then switched and talked about how to access the data and all of the different choices. And while all of them are valid choices, it's generally a very good idea to create mapping classes for the objects that are stored within MongoDB. So we did that. We created a shipwreck mapping class. And then finally, we did a find specifying a particular subset of the data that we wanted to get. We then did a little bit more refinement of the app, moving the creation of the Mongo client out to the startup file and adding the URI to the appsettings.json file. And with that, I would like to thank you very much for joining me today in this talk. I'd also like to give a quick shout out to a new course we released just this spring called M220N. It's the .NET version of 220. It's a 5-week course where we dive into using the .NET driver in much greater detail. And you get the opportunity to work on a website called Mflix, which is a movie database. We walk you through a lot more things that you can do with the driver, including some fairly complex work with the aggregation pipeline. So I encourage you to check that out. It's at university.mongodb.com and just search for M220N. Thank you very much for attending this talk. I hope you enjoyed it. I hope you learned a lot, and I look forward to your questions.